Welcome back to Programming with Qt Widgets. In this episode, we'll talk about this one, namely, how do you get colors onto your pixels, either on screen, in an image, on a printer, or somewhere else. Before we proceed with today's lesson, let's do like this. I can snap my finger and just like a Time Lord from Doctor Who, I am now back in time. I'm back at 1993. Just down the hall from here, two friends are sitting about to implement what you know as Qt these days. They just implemented or invented Qt Widget, and now they're discussing how to paint on that. And while it might feel weird to pause time in 1990 something, try to do it nevertheless and think about how you would implement it. Likely, one of the guys suggested, let's add a draw line, let's add a draw rectangle, let's add a draw ellipse, and other draw methods to this new QWidget class. And QLabel can override this, or might not be able to override it, but can use those methods. QImage can use those, QWhatever can use those methods. But the other said, let's instead create a new class. Let's call it QPainter. And the QPainter will operate on the QWidget, and drawing through the QPainter methods will then end up in the QWidget. The implementation of draw rectangle, how you calculate which pixels should be painted, is in that separate class, which on its own is nice, but it has some much neater effects that we'll see on the slide once we get back to 2024. And Robert, please do remember to rewind the tape, will you? Now, back in today, past for you, I guess. What we notice is that we paint using this class called QPainter. So to draw pixels on a widget, I'll create an instance of QPainter. I'll specify the widget in the constructor, and that is where the painting will actually happen. The QPainter is operating on a class called QPaintDevice and QWidget subclass that. And why is this so smart besides having the methods in that other class? Well, it's smart because anything that inherits the API of QPaintDevice can now be painted on. And have a look at the slides here. You'll notice that I can paint on QWidget. Obviously, QQuick painted item. So if you are in QML land and you want to draw something, you can create a custom widget in custom item, I guess it's called in QML. Then you can subclass QPainted item and paint on that. QImage and QPixmap, I'll get a bit back to the difference between those, but that's a container that you don't see on the screen that you can do some operations on, and then eventually put it on the screen or put it somewhere else. And others, one of those that I'll show you a bit later in this episode is QPrinter. So you can print very simply by just creating an instance of QPainter on a QPrinter, do your painting, and voila, it will show up on paper. QPainter provides the API of drawing, so you can paint lines, you can paint shapes, text, and pixmaps and whatnot. I'll show you all of those in one of the following episodes. Finally, you also control the rendering quality through the class QPainter. And we see that on the next slide, I believe. Okay, the next slide and one. Because before we do that, I'd like to take us back in time, not as far back as before, but back to an episode that we recorded in the series here months and months ago, for me at least. You might have watched it yesterday, I don't know. It was about painting. We had a small interlude where I showed you how to paint using events. And let's just review that. So painting is done in the method QPaintEvent. That's the only place where you're allowed to create an instance of QPainter and actually put pixels on the screen. Why is that? Well, That's because that Macintosh insists on doing double buffering for you. So you have to have Qt call you to be able to paint. Obviously, you can paint in any methods, but the backtrace needs to start in a paint event. Okay, so how do you get to paint? Well, you can do that in two ways. You can either call repaint or you can call update. Repaint basically, through a number of pointer indirections, number of function calls the paint event for you. So it basically goes to Qt and say, hey, can you please call back to me and set up your backing storage for doing the double buffering, and Qt will do that. Or you can call update. An update will simply put an event into the event queue that says that whenever you have a minute, please do come and call my paint method. I actually put out an episode on Qt Widgets and more about the difference between repaint and update, and it took me a lot further into the event system of Qt. So once you're done watching this, go to the episode notes below and find that episode. It's rather interesting. As I said, Qt handled double buffering. And what is double buffering? Well, remember how you draw yourself on a piece of paper, I mean. Will you take, if you want to draw a house, will you take and paint each individual cell on the paper? Or will you draw a rectangle, and then when you've drawn that rectangle, you draw another rectangle, the window on top of the original one? Very likely. And that's how you do it when you do painting with computers too. You'll paint the same pixel multiple times. So it could be that you first painted a full red rectangle for the red brick house, and then painted inside there a yellow rectangle for the lit up window. And once you've done that, if you look carefully at the pixel that is in the window, you'll see that that pixel was white. Then it became red, and then it became yellow. But we don't want to see that transaction on the screen, because that would be considered weird at best, flickering at likeliest. Is that even a word? Anyway, that is what double buffering about. What you really do is that you do all your painting off screen, and then Qt takes those pixels and put them onto the screen so that that flickering doesn't happen. One thing that you need to be aware of when you paint to widgets is that widgets by default are transparent. So if you want to paint to a widget as the background color, then you need to call set autofill background. And that's it. Let's head over and see the example once again. Welcome to the magical world of Qt. But that was not your starting point, was it? You had, for example, a larger application in .NET, and now you'd like to learn Qt, which you're doing now. But how about the C++ side of it? We can teach you that too. Reach out to us for a C++ training. So here's my main very simple application. Well, I can run the application for you. You can see it is truly very simple. And here is my house. It would be red here, and here I'm drawing the yellow windows and the green door. And well, yeah, not that good at drawing, I guess. What you'll see in here is that I create an instance of this class scribble area, I resize it, and in here we have the class itself that we are painting on. It's a Q widget, so it needs to be, otherwise I wouldn't see it on screen. Of course, it could have been a Q frame if I wanted it to be framed already, because that it was sitting in some context, I don't know. But it's a Q widget here, and it has a constructor, and it has these three methods: the mouse press, mouse move, and paint event. And the mouse press and mouse move is where I record the movement of the mouse when I'm drawing with it, and the paint event is where I actually do the painting. And if you just move to the mouse move event here, you can see I'm drawing something here, and in my mouse, well, that was the mouse press. So I press the mouse, remember where it was, and then I move the mouse to a new position. That gives me a mouse move event. I will be drawing in this im_drawing, which is a QPainter path. It's just a data structure where I record where I'm painting. I'll do that to that data structure. No pixels on the screen yet. But what I'll do is that I'll call update. Update will call right into, or we'll put an event into the event system, which will then be triggering my paint event. Paint event takes some parameters here. It could be that I had a widget that was super slow at painting for whatever reason, and I wanted to know what part of it I needed to repaint. Then I could look at the paint event parameter here. Likely you need to do something else if you have that kind of problem, but that's the idea with the parameters to paint event. In here, I create now a QPainter on this. I set the pen to be 3 pixel thick and be a black pen. I'll talk about the different pens in a follow-up episode. And now I draw my painter path. So every time I move my mouse around, I update the backend data structure. I ask Qt to repaint me. Whenever Qt has a time, it will come back to me and ask me to paint, and I'll paint the entire widget every single time. So when you paint, you actually fill out a grid of pixels, and each pixel is the smallest possible unit. It can have one color and only one color in it. It can't have a partial color or a color partial part of the pixel. Hopefully that's not a big surprise for you. But if you look at this screenshot we have down here, so this drawing we have down here, you can see, first of all, notice that the pixel goes downwards. The coordinate system for the pixels is downwards, which is like, did they really need to do that to me? I have been spending 250 years in school learning that the y-axis point upwards and now it points downwards. Well, that's actually something you can do about that. I'll talk about coordinate transformation a bit later in this episode. Not this episode here, but in this module here. But you notice it points downwards. Okay, cool. And then I want to draw a line from here to here. In mathematical terms, a 1 pixel thick line from here to here, that would look something like this. But I cannot draw partial pixels. We already agreed to that. So what I can do, my coordinates is representing the topmost leftmost corner of my pixels, as you can see here. And then I can paint from here to here by painting a rigid line like this. Or I can use a trick that was invented like before I was born. That's called anti-aliasing. And that's what you see here, where you paint not only the pixel in that line here, but also some of the pixels around it. And if you do like this, and look at come on, give it a try. Oh, what that sound was, well, I installed some malware on your computer and now I take a picture of you looking really weird. So please transfer some money to this Bitcoin. Never mind. What you'll see here is that I paint some pixels around, and that's the anti-aliasing effect. And if you are far enough away from it, this line will look more smooth. Obviously, this looks almost more smooth than this line here, but we've zoomed so much into these pixels. You specify that you want this setup rather than this setup using render hint, and set render hint has a number of different, let's just go here, render hint, anti-aliased, text anti-aliased. So obviously anti-aliasing text is likely more expensive than just anti-aliasing a regular line being drawn. Smooth pix maps, transform, and so on. There's a lot of these different things. Lossless image rendering. So if I render an image or come on, read the text yourself, will you? Okay. So this is specified using set rendering hint. Are you boggled in? Because now it's getting really hairy. Not. In Qt we have a number of helper classes, but they nevertheless are useful to mention. If for no other reason, because they have some surprising features. So first of all, we have a QSize class to represent a size that is this amount of pixel width and this amount of pixel height. And we have a class called QSizeF for taking these as floating point numbers rather than as integers. And the reason for that is if you do some transformation for example, zoom far in, then regular size might not be enough for you. Then we have a point, x, y, and as you have a rectangle down here, you can specify there's a number of overload with rectangles. One that takes 4 parameters, x, y, width, height, but sometimes it's more easy to read if you just create explicit a QPoint and a QSize in there. I guess by now I don't care much myself because I know that it's x, y, width, height, but for your new coworkers, it might be easier for them to read if you explicit specify that one is a point and the other is a size. We have this class called QLine, and please in the notes below let me know whenever you ever used the QLine class. Personally, I've never used it in my 25 plus years of careers with Qt. And here is the part where it's useful to point out that your QRect class actually has the ability of doing some not very difficult calculation, but nevertheless, I have a size here that's 100 and 100 and a 0.00. I create my rectangle for this, and this might be that I want to just create the illusion of a frame around a picture. So I can start drawing the whole rectangle here with this size completely black, and then I'll take my rect and I'll adjust it 10 pixels in from each side, from the x and y, and from the left and top, and from the right and bottom I also adjusted 10 pixels in. So now we have taken 10 pixels each side around, and using that I can draw my pix map, which then gives me a huge black frame around my image. Why would I do that? Well, I don't know. It's just an example. I can also go and ask the rectangle for the point where the center is. Again, not rocket science, but do not take these for just face value. To go and read their APIs. There's more than meet the eye. What we'll start talking about next time is color handling in Qt. And then we'll follow up with 2 really interesting, if you ask me, episodes. Namely one where I talk about the painting operation and the transformations. And after that, we'll see some mind-boggling things about which pixels are actually drawn when you do anti-aliased drawings. So, until then, have a great day.